2.4 Part 2, Linear Functions and Slope. So on this part of the section, we're going to look at graphing using slope-intercept form, which we should be really familiar with. Slope-intercept form right here is y equals mx plus b, where m is the slope and b is the y-intercept. So last time we talked about what slope is, we also talked about what the y-intercept is. The y-intercept, remember, is where the graph goes through the y-axis. And then for slope, remember that slope is the rise over the run. With those two things in mind, we'll be good to go. We'll be good to graph. On each of these problems we're doing, like example 1, it says give the slope and y-intercept of each line whose equation is given, then graph the linear equation. So, what we can do is say m, which is the slope, is whatever's in front of our x, and so what's in front of x right now is 2. And for the purpose of graphing it here in a second, we want to make this a fraction. So if it's not already a fraction, remember, you just put it over 1, and now it's a fraction. Then for our y-intercept, which is b, that's the number that's not right next to x. That's either being added or subtracted at the end, so b is -1. The way we graph this is we begin with b. We begin with the y-intercept. And so we're going to go to -1 on the y-axis, and we're going to put our point. And then we look at our slope, which is our rise over our run. So we are rising 2 and we are running 1. Both of those are positive, so we're going to go up and to the right, because those are the positive directions for our coordinate system. So from the point I already have drawn, I need to go up 2 and right 1. And here's my next point. And then I can do that again, up 2, right 1. I can do it for the whole place I have that I can graph if I want to. Or I need you to do it at least twice, unless the slope is too big for you to fit twice. Okay, so up 2 over 1, there's my line that goes through -1, has a slope of up 2, right 1. Okay, so on this one we have the same instructions, but m is the number that's being multiplied to the x, so that's -3/5. b, in this case, I don't have anything that's being added or subtracted out here, so what we would do is we'd put a +0. Because if I add 0 to this, it doesn't actually change the problem. If you add 1, it's a completely different line. Okay, but we can say, okay, well, b is 0 because there wasn't actually a y-intercept. There wasn't anything there. So we begin with the b, so at 0 on the y-axis, that's where we're going to go through. Now, whenever we have a situation like this, where we've got -3/5, the negative goes either on top or on bottom. Okay, and so what we can do is we can look at, well, what is a rise of -3, which means down 3, a run of 5, like where is that point? That point is right here. Or we can look at it as the second way, that it's a rise of +3 and a run of -5. A run of -5 goes backwards to right here. So you see that actually helped us draw more of our line. Okay, by going, at one point we went down 3, right 5, then we went up 3, left 5. So that's how you deal with a negative slope. Now we want to talk about solving for y. So on this section it says A, rewrite the given equation in slope-intercept form by solving for y. It's really actually pretty easy to solve for y because you always end up doing the same thing. We always want to either add or subtract our x over to the other side. So since that's a positive 2x, we subtract it to the right side, so that now I have negative 3y equals negative 2x plus 12. And then since that negative 3 is in front of y, we want to divide everything by a negative 3. Okay? Every single thing needs to be divided by negative 3 in order to get that negative 3 away from the y. Well, let's look at this first. A negative 2 divided by a negative 3, the negatives cancel out, but we want to leave it as a fraction. Don't change it to a decimal. It'd simply be now positive 2/3 x. 12 divided by negative 3 gives us a negative 4. So this is part A. We just solved this for y and wrote our equation in slope-intercept form. Part B asks us now to give the slope and the y-intercept. So remember, our slope is what's in front of x, and our y-intercept is what's being added or subtracted out to the side. And then part C, they want us to graph it. So I start with my y-intercept, which is at negative 4, and then I look at my slope. My slope is up to right 3, which goes to here, or I could go the other direction. I could go down to left 3, draw my point right there, and then it's simply the line that goes through those points. Now, these are two different equations. We want to talk about basically vertical and horizontal lines. So we're going to graph this on the same xy axis. If I graph x equals negative 2, what I want to do is I want to go to negative 2 on the x-axis, which is right here, and then I draw an up and down line. Okay, because if I have x equals negative 2, then that's a vertical line. Anytime it's x equals a number, it's a vertical line. Anytime it's y equals and all we have is a number, it's a horizontal line. And that's because since it's y equals, if we think back to our y equals mx plus b equation, the 5 is the y-intercept. But I don't have an x at all, which means that m has to be 0. So really this equation y equals 5 is y equals 0x plus 5. So our slope is 0, our y-intercept is 5. Well, that means that I'd go to 5 on the y-axis and draw my dot. A 0 slope is a horizontal line. So that line kind of sucks. Please forgive me. Okay, so if you see y equals 5, or y equals something, that's a horizontal line. If you see x equals something, that's a vertical line.